During the Middle Ages, ship trading expanded as it became cheaper and safer to traverse the world's oceans and seas. In the centuries that followed, the developments of ocean-going warships and efficient merchant carriers also led to a rapid expansion of commerce. But it was the 1859 discovery of oil by Edwin Drake in Titusville, Pennsylvania, that would bring overseas shipping to new levels of prosperity. 2 years after striking black gold, 3 million barrels of oil were being pumped each year in Titusville, with the majority of it being refined into kerosene. Coined the new illuminant, kerosene created a demand that stretched across the Atlantic to an oil-thirsty European continent. In November of 1861, the Elizabeth Watts made the first transatlantic shipment of oil from Philadelphia to London. Storing the cargo in wooden barrels, the double-masted 224-ton wood ship carried 1,329 barrels of oil on her maiden voyage.
And those barrels had value, so having reached their destination, they were emptied and were then shipped back empty. So at the time it was considered an efficient system, but shipping back empty barrels was not efficient.
The barrels, which each held 42 U.S. gallons, accounted for up to a fifth of the ship's actual cargo weight. In 1886, British shipbuilders improved on the inefficient barrel with what most consider to be the world's first modern oil tanker, the iron and steel constructed Glukov.
That ship utilized the hull of the vessel as the containment system. It was able to carry a larger cargo, steam-powered, wasn't so dependent on the weather, and it meant that one could actually organize the transportation on a more regular basis.
The Glukov could travel at a rate of 9 knots, holding 3,020 tons of oil in 8 storage tanks that were subdivided by a series of vertical and horizontal bulkheads. Oil was pumped into the cargo tanks from shore and was protected from leakage by boiler-riveted steel plating that also formed the outer wall of the tanks. To further maximize the amount of oil that she could carry, the ship's cumbersome engine was moved from middle to far aft. The bridge tower and officers' quarters were relocated to the middle, and the smokestack and crew's quarters placed at the stern. The bow of the ship was home to a raised forecastle that protected her against rough seas and provided storage for supplies. The Glukov's distinct 3-island structure became the standard for tanker design for more than 60 years. In the early 1900s, the world's deep-sea tanker fleet numbered 145 ships, with trading between the United States and Europe reaching 2.3 million tons of crude a year. The largest tankers in the fleet had a cargo capacity of 12,000 tons, nearly 4 times that of the Glukov. But this increase in tanker size began to compromise their seaworthiness. Sir Joseph Isherwood came up with a solution in 1906.
When the ship's going through the waves, it's moving up and down and bending in a longitudinal way. And the Isherwood system was developed to provide some longitudinal rigidity to help the vessel in terms of its bending.
Before the Isherwood design, ships were built using numerous transverse frames, which formed the ribs of the ship. In Isherwood's design, the ship's frames ran fore and aft along the length of the ship, parallel to the keel. The frames were then connected to the keel by vertical bulkheads, which also divided the tanks. By 1914, 276 ships had incorporated the Isherwood design.
The Isherwood system has been refined and modified, but it is still the underlying system that is employed in the construction of ships.
The design system for the modern oil tanker had been achieved. But the onset of the First World War would bring about a new breed of tanker for the military, called an oiler, and a new method of transferring oil, known as underway replenishment.
The tanker is a ship that's able to carry petroleum or water or some other liquid substance from point A to point B. An oiler can do that, but it also can do what the Navy calls underway replenishment, whereby it can refuel other ships while sailing across the ocean.
In World War I, the strategy of the German Navy focused on Britain's dependence on oil imports to fuel its war campaign. Germany's new weapon, the U-boat, set up a blockade in the North Atlantic to cut off Britain's oil supply. When the U.S. entered the war in 1917, the Royal Navy was limited to a 10-week supply of oil. With little time to spare, the U.S. Navy sent a fleet of destroyers to assist the embattled British fleet.
These destroyers had a very limited range. They could just barely make it across the Atlantic. To ensure that they wouldn't have any problems, the Navy arranged to have them be refueled in mid-ocean by one of the Navy's oilers.
Before the U.S. joined the war, Chester Nimitz and the officers aboard the Navy tanker Maumee designed a ship-to-ship refueling system that consisted of two 50-foot-long rubber hoses suspended by cargo booms. The Maumee was the first ship to perform underway replenishment.
The advantage of underway replenishment is that the fleet or Navy formation can keep steaming while it is refueling, as versus having to go to a port somewhere and spend the time to refuel and then proceed on to its destination.
By July 5, 1917, the Maumee had refueled 34 destroyers headed for Europe. They helped break the German U-boat blockade.
The significance of refueling these destroyers was it was the first time that anyone had refueled ships at sea in a tactical operation. And it was the forerunner of something that would happen again and again, especially in World War II.
In the mid-1930s, war clouds began to form again on the global landscape. The United States military was quick to realize that if a Second World War were to erupt, it would be a fully mechanized conflict, and tremendous amounts of oil would be needed to ensure victory.
The Navy laid out a very detailed structural plan on how the Navy was going to get from the west coast of the United States to the Far East to be able to engage its main enemy, which it felt was Japan. So it knew in the interwar years that refueling at sea would become a critical element of this.
The Navy needed a fleet oiler in a hurry and looked towards the commercial tanker industry for assistance. In 1939, the Navy purchased the 553-foot tanker Cimarron from the Standard Oil Company.
She was a very unusual ship. She was fairly large, but more importantly, she had twin screws. It's a very fast ship with a bulbous bow. They allowed the ship to have a speed of 18 knots at a time when 14 or 15 knots was the norm for a fast commercial tanker. And this speed was very important because this would allow the ship to steam with the fleet.
The Cimarron became the prototype fleet oiler for the Navy. When the U.S. entered the war after the bombing of Pearl Harbor, the Cimarron class quickly distinguished itself in the battle for the Pacific.
The real significance of the Cimarron class was that it permitted the United States to conduct the famous carrier raids that we're all familiar with. It's a little-known fact that every one of those raids was accompanied by an oiler. And this was because the destroyers all had to be refueled at sea because they had limited range vessels.
In addition to refueling at sea, the U.S. military needed to transfer millions of gallons of oil to the thousands of tanks, trucks, and planes that would be needed in Europe and along the Pacific fronts.
Tankers were always a prime target of U-boats because they're important ships. Their cargo is important, so whenever a submarine saw a tanker, it would always go after it.
The Allied forces were faced with the challenge of building tankers faster than the Axis powers could sink them. Their answer was the T-2 tanker.
It was a standard design which allowed the ships to be built very quickly.
They actually would construct segments on shore and then bring them to the building yard, and each time they built a tanker, They learned how to build it faster or quicker.